Hi YouTube, I'm back again for another episode. It was a long time that I couldn't actually post anything because I was moving to another city, and as you see, still my room is chaotic, and there's a lot of things that I have to do. But because I don't want to miss any chance to post new episodes, I would like to dedicate this one to TX-86, the robotic platform that I have designed to spot welding. So I would like to explain what is exactly a spot welding, and then to see a simulation of a spot welding, robotic spot welding on TX86, and to see how it looks like. And also I will put the codes of Robot Studio, which I have used also the trial version on my podcast website, and you can download it if you want. And if there is any question, please just comment and ask me. I would be happy to answer. Thanks a lot, and let's see the video together.
Spot welding or resistant spot welding is a type of electric resistance welding used to weld various sheet metal products through a process in which contacting metal surface points are joined by heat obtained from resistance to electric current. The process uses two shaped copper alloy electrodes to concentrate welding current into a small spot and to simultaneously clamp the sheets together. Workpieces are held together under pressure exerted by electrodes. Typically, the sheets are in the half to 3 mm thickness range. Forcing a large current through the spot will melt the metal and form the weld. The attractive feature of spot welding is that a large amount of energy can be delivered to the spot in a very short time. This permits the welding to occur without excessive heating of the remainder of the sheet. The amount of energy delivered to the spot is delivered and determined by the resistance between the electrodes and the magnitude and duration of the current. The amount of energy is chosen to match the sheet's material properties, its thickness and type of electrodes. Applying too little energy will not melt the metal or will make a poor weld. Applying too much energy will melt too much metal. Ejection happens and it will eject molten material and make a hole rather than a weld. Another feature of spot welding is that energy delivered to the spot can be controlled to produce reliable welds. Spot welding is typically used when welding particular types of sheet metal, welded wire mesh, or wire mesh. Thicker stock is more difficult to spot weld because the heat flows into the surrounding metal more easily. Spot welding can be easily identified on many sheet metal goods, such as metal buckets. Aluminum alloys can be spot welded, but their much higher thermal conductivity and electrical conductivity requires higher welding current. This requires larger, more powerful, and more expensive welding transformers. Perhaps the most common application of spot welding is in automobile manufacturing industry, where it is used almost universally to weld the sheet metal to form a car. Spot welders can also be completely automated, and many of the industrial robots found on assembly lines are spot welders. So as you see, I have modeled this platform in Robot Studio, and I just want to show how it works. It's basically a platform, a robotic, a hydraulic platform, which the electrical cabinet is integrated, the hydraulic circuit and the hydraulic pump is also integrated. It is based on four-cylinder that, when it is needed, can lift up the whole platform up, and with omnidirectional wheels, the and four motors that is attached directly to each omnidirectional wheels, the platform can move. Also, there is a pack of battery line integrated underneath uh, the platform, so it means that it can easily switch from DC to AC and from AC to DC with a converter, also into place on the platform. And in this model, I have used a ABB robot, which can be used for spot welding. I have created in fact, teach the tags and the points that is needed to do the spot welding, and also I have tried to simulate the gun, the spot gun, how to reach to the points that is needed on the metal sheets, and how to be activated. All these information are provided in my website, in podcast website, and the text, and you can actually get to the text and realize how you can also work with the signals, because the signals needs to be triggered. Usually it's like that. If you want to trigger a tool, for example, closing, opening like a gripper, or just activating the welding system, you have to communicate with the PLC. And in the electrical cabinet, I have considered a PLC from Siemens, 12,000. And in this PLC, there is a communication. So the PLC plays a role as a master, and the robot as a slave. So it means that we will ask where to activate the gun, and also where to activate the gripper. In this example, we have also considered to a rail system that the robot can reach to the desired, even if the platform is stationary. Of course, it's easy to move the platform to somewhere else, and that's actually the benefit of this platform, is that it's movable, and someone can easily move the platform to the next station, and the job can be done in that place. So you don't need to buy a lot of robots. You can basically put this robot on this platform and move the platform to the specific place, and then you can fix it there, and then the robot can do the job. The only thing is that the calibration needs a little bit timing, but it also can be done automatically. But this platform basically is not an autonomous platform. It means that someone needs to somehow control the movement of the platform to the desired place, and then after that, the program or the pre-program of the robot can be carried out. And in this example, as you see, I have considered rail, and I have provided it gives extra freedom for the robot to reach to places that is not possible if the robot was fixed on the place. But it's not a must. You can design whatever you want. You can place your robot stationary, and then if it is needed, just make a rail that has more reachability. So in this example, I tried to show the spot welding, how it works, and as you see, after the robot has done the job, it will goes back to the home position for the next project, or for the next job. I hope that you have enjoyed this episode, and as I said, you can reach the text and codes in my website. See you next time.